Hello everyone, welcome to Kriti Tutorials. Today we are back with a very important topic, that is factorization. It's a very important topic for 8th standard, 9th standard, 10th standard. So let's take few important questions for the same, right? So now let's come with the first question, which is based on middle term splitting, right? So we have to factorize the given polynomial, that is 7 root 2 x square minus 10x minus 4 root 2. So we can solve it in a very easy way. Sometimes we face the problem because of root sign, right? So I'll just tell you a very simple way to solve it. So as we know, we have to take the product of two terms, right? That is the coefficient of x square and the constant term, right? So let's take the product of the two terms, 7 root 2 into 4 root 2. So 7 fours are 28 and root 2 into root 2 is 2. So what's the product? 56. So now we have to think of two numbers whose product is 56. Okay, so let's consider A and B whose product is 56. So you can think of 28 into 2, you can think of 8 into 7. There are many more, right? So now you have to check the product of two numbers is 56. And if you check the sign of 4 root 2 here, or the sign of the product, 7 root 2 is positive and minus 4 root 2. So the sign is minus. So we have to think of two numbers whose product is 56 and whose difference is 10. Don't take minus 10, that will be more confusing for you. Just ignore the sign of the middle term. So here a minus b is 10 and AB is 56. Now what's the easiest way to do it? We can do middle term splitting with prime factorization. So if I divide it, I get 28. If I divide it, I get 4, 2 and 2. Right? So now if I just make the pairs, if I just group these factors of 56, I can get my answer easily. So now if I group 7 and 2. What will I get? 14. I group 2 and 2. So what will I get on multiplication? 4. And if I see that subtraction of 14 and 4 is 10. This is a very easy way. So 14 minus 10 minus 4 is 10, right? And 14 into 4, if you do, that is 56. So it's a very easy way to do the middle term splitting. So we can write here 7 root 2 x square minus, and in bracket you can write 14 minus 4 x minus 4 root 2. So what will you get now? If you open the bracket, minus 14x and minus minus plus 4x minus 4 root 2. Now we will make the pairs. We will do the grouping of two terms and then we are going to do factorization. Now what is common in 7 root 2 and 14? Right? Just check. So that is 7 root 2 common. And from the variables what is common? X. Correct? So what will you get? X minus root 2. Few students might not be clear with 7 root 2. Now I will just explain you in short. What is the factorization of 14? 14 is 7 into 2, right? And what is 2? Root 2 into root 2. And this is how we did the factorization for 14. So 7 root 2 common. So what is left? Root 2. Now from the next group, 4 is common. And in bracket we get x minus root 2. Now again x minus root 2 is common. So what we will get? 7 root 2x plus 4. So this is our final answer. So though it has roots, but it doesn't mean it's tough. You just have to stick to the concepts which you apply to the non-root questions, right? So in factorization, remember, middle term splitting is the same concept whether we have the terms in root or not. Is it clear to everyone? Let's move to the next question now. Now x square plus 3 root 3 x plus 6. Again it has root in it, right? So being containing the root, what we have to do? We have to move on with the same concept, but now the terms are different, right? Now let's move on with that. X square plus 3 root 3x plus 6. Correct? So x square plus 3 root 3x plus 6. Now again we have to do middle term splitting. Now the coefficient of x square is 1. So 6 into 1 is 6. Now what we have to do? We have to do the middle term splitting for 3 root 3. Right? So we have to take two numbers whose product is 6 but whose sum is 3 root 3. Now again, a little bit tricky you can say, but very simple again. Now if I just do the prime factorization of 6, there are only two prime factors, right? 2 and 3. So if I make the factor 3, I can get 2 and 3, but it doesn't have a root. Now we can introduce the root. How we can introduce it? Now if you see, 3 into 2 can be written as 3 root 2 and root 2. Right? This is one of the way to write it. Clear? Now what do you have for the other thing? You can have either root 3 into root 3 into 2. Right? We can either split 2 into root 2 and root 2, or we can split 3 into root 3 and root 3. For this question, we have root 3 here. Right? So for us, the second one is better. Right? So what we can write? We can write it as 2 root 3 as one and root 3 as the other. And if I add both of them, 2 root 3 plus root 3 is 3 root 3. So that we have to check. It has only two factors, 2 and 3. Listen again. So we can either split 2 into root 2 and root 2, or we can split 3 into root 3 and root 3. Here we will use 3 ka splitting because we need 3 root 3. So 2 root 3 is one and root 3 is the other. And the sum of the two is 3 root 3 and the product is 6. So what will you write here? We will just substitute it, right? If you want to write one more step, you can write 2 root 3 plus root 3. This is how we are splitting the middle term. Now let's make the group of the two terms. So what is common in the first one? X. No, nothing common in the variable. In the other one, what is common now? Root 3. X plus 2 root 3. Now again, why 6 may say if we have taken root 3 common, 2 root 3 is left out. Again you have done the same thing here. I will recall it. 3 is 3 into 2. 3 ko we have split it into 2, root 3 and root 3 and 2. So if I take root 3 common, what is left out? 2 into root 3, right? So this is what we have done. Now what is common? X plus 2 root 3 factor is common, and what is left? X plus root 3. So this is what we do for the factorization of x square plus 3 root 3x plus 6. So both the questions were based on middle term splitting. No need of any identity or anything, just middle term splitting, right? Now let's take the next. X square minus 4x, x square minus 4x minus 1 minus 20. So here the point is we have to do a substitution, because now if we open it and do it, it will become 4-degree polynomial. So to make it a simple one, let's put x square minus 4x as t. How we will come to know that we have to substitute x square minus 4x as t? By seeing the term which is getting repeated. So if I substitute it, I get t and t minus 1 and then minus 20. So t square minus t minus 20. So it becomes a simple question of quadratic polynomial which can be factorized using middle term splitting. Yes, middle term splitting, which you all easily can do now. Right? So 20. What are the factors for 20 if I just take 5 and 4? So we need two terms whose product is 20 and whose subtraction is 1. Right? If this is A and this is B, I can simply say 5 minus 4 is 1. So nothing to think much. So t square minus 5 minus 4t minus 20. So we get what? T square minus 5t plus 4t minus 20. So t is t minus 5, and if we take 4 common, we get again t minus 5, right? So we have done so many questions related to this. Now what's the next step? Next step is we have to resubstitute whatever we substituted first. That is, we have to give the answer in x variable only. So if we have to give the answer in x variable, I have to resubstitute it. And then again we have to think whether it can be refactorized or not, because now again it's a quadratic polynomial. X square minus 4x plus 4, x square minus 4x minus 5. Again it is a quadratic polynomial, and being a quadratic polynomial, we can still factorize it or not, that we have to check. Now if I check for the first one, can it be factorized, students? Yes, we can do the middle term splitting for the same. How will you do it? X square minus 4x. 4 ko we can split into 2x and 2x, because we need two terms whose product is 4, and on addition you get 4. And for the next one, what do we need? We need two terms whose product is 5, and on subtraction you get 4. Is it possible? Yes, very good. We can do it still, right? So we get this. Right? Now what will you get here? X minus 2, and minus 2 again, x minus 2. X common again, x minus 5 plus 1, x minus 5. So what is common here? X minus 2, x minus 2. And what is common here? X minus 5, x plus 1. So it has four factors, because as we discussed that being a quadratic polynomial, we have maximum two factors, and now the degree of the polynomial was 4, so it will have maximum 4 factors, right? So this is what we have. So x minus 2, x minus 2, 2 are same, so it has in all, if we check, 3 zeros only, right? Because 1 is getting repeated, right? The 0 polynomial, that is 0 of the polynomials are 2, 5 and minus 1 also, correct? Just check everyone. Now let's move to the next. Now again it's a question of factorization, but it can be done with identities also. X plus 1 whole cube minus x minus 1 whole cube. Now we can do it with the use of identity. Now you can use two identities here, either a plus b whole cube, a minus b whole cube, and you can also use a cube minus b cube, right? So two ways are there to solve this question. We will take both the ways here, whichever you feel like, whichever you are confident, whichever you understand better, you can use it, right? So now let's take it. So what do you get? If I take this as a, right? If I take this as a and this as b, that is x plus 1 I am taking as a, and x minus 1 I am taking as b. So I can use the identity a cube minus b cube, which is a minus b, a square plus ab plus b square, right? A minus b, a square plus ab plus b square. So what will you get? You will get here x plus 1. Now minus sign is there in between, so you have to be very careful. Don't miss the step, just put it in bracket first. Okay, so you get minus of x minus 1 in the bracket. Correct? Now a square is x plus 1 whole square. AB is x plus 1, x minus 1, and b square will be x minus 1 whole square. So now if I open the bracket, what will I get? X and minus x will get cut. 1 and minus 1 will not get cut, because minus minus is plus. So you will get 2, 1 plus 1. Okay, now let's open the other brackets. A plus b whole square you will apply here. Here you can apply a plus b, a minus b, which will be a square minus b square. And here again you can apply a minus b whole square. So you get these terms, right? So what's your answer? 2 times x square plus x square plus x square. How many times you have? 3 times. And Anything else you have? Yes, one more, 1 you have. So this is your factorization using the identity a cube minus b cube, right? So this is one way of solving it. If I show with the alternative method, right? Alternate method is using a plus b whole square and a minus b whole square. So what will you get? A plus b whole cube, sorry. So a plus b whole cube is a cube plus b cube plus 3a square b plus 3ab square. And what will be your a minus b whole cube? A minus b whole cube is a cube minus b cube minus 3a square b plus 3ab square. So we can use these two identities for x plus 1 whole cube and x minus 1 whole cube. So what will you get? Your a is x and your b is 1 here now. Correct? So what will you get? X cube plus 1 cube plus 3x square, because 1 if we write it's okay, if we don't write then also it's okay, because 3 ones are 3, and here we get 3x. 1 square is 1. Now minus sign is there. X cube minus 1 minus 3x square plus 3x. Now let's open the bracket. So now be careful with the minus signs, please, so that you don't make the error. So if you open the bracket, sign of all the terms inside the bracket will change. Just keep it in mind. So minus x cube, minus minus plus, plus, and minus plus minus. Now let's check. This is getting cut. This is getting cut. So what will you get? 2 plus 3x square plus 3x square is 6x square. Now what is common? 2. So what will you get? 3x square plus 1. Oh, sorry, we wrote here by mistake. I wrote cube, right? We had x square, x square, x square 3 times. So we are getting the same answer with both the methods, right? So just check, you can solve it by using a cube minus b cube identity, as well as by using a plus b whole cube and a minus b whole cube. Whichever method you find easier to solve, you can use that method, right? So we can solve it in two ways. Clear to all? Let's move to the next question. So x raised to 12 minus y raised to 12. You will think we don't have any identity for 12 power, right? But we can still solve it by making it in the form of square or cube. You have identity for both square as well as cube, right? So if I make it the power of, suppose, 2, okay, so how will you write it? X raised to 6 raised to 2, y raised to 6 raised to 2, right? So now we can use the identity of a square minus b square, which will give you what? A plus b and a minus b. So what can it be written as? X cube minus y raised to 6, x raised to 6 plus y raised to 6. You can directly raise to cube power also, right? Now, x raised to 6 minus y raised to 6, x raised to 6 plus y raised to 6. Now, 6 can be reduced to cube power as well as to the square power. So, let's reduce it to the cube power now. Right? So, we can write it like this. Correct? Now, a cube minus b cube. We just did it in the previous question also. So, what will it be? A minus b. So here your x square is a and y square is b. Okay, a minus b, a square, that is x raised to 4, plus b square, that is y raised to 4, plus ab. Ab is x square y square. Right? Now we will use the identity a cube plus b cube in the next factor. Right? So what we will get? X square plus y square, and here we will get x raised to 4 plus y raised to 4 minus ab. Clear? Now, we have to check, can we still factorize any of the term, any of the factor? Yes, we can factorize x square minus y square using the same identity which we used in the first step, that is x plus y, x minus y. So this can be factorized to this. Now, for rest of the terms, we can write as it is. We don't have any identity for a plus a square plus b square. So this will be written as it is. See, factorization is based on the product of the terms. That's it. So whenever you are getting the product of the terms which cannot be further factorized or which cannot be further broken down into simpler terms, that makes your answer. It doesn't matter how many terms we have. See, power was 12. 12 means we can have 12 factors. So, right? So, we can easily factorize it using the identities. So, here we have x plus y, x minus y, x raised to 4 plus y raised to 4 plus x square, x square plus y square, x square, x raised to 4 plus y raised to 4 minus x square y square, right? Clear to all. So however the large the power is, you can easily reduce it to the squares or the cubes. Now let's see the next. Now this is again based on cubic identity, right? Either you can use, again as I said, we can either use cube square ka identity or cube ka, but here cube is already there, we don't have to reduce it to the square. 8 ko what can we write? We can write 8 as 2 cube, right? X plus y whole cube minus 3 cube x minus y whole cube. Now we can join the two things together. How? 2x plus 2y the whole cube. 3x minus 3y the whole cube. Now this makes your question very easy now. All of you can do it now. It's in the same way as we did the previous question, right? That is what we did, x plus 1 whole cube and x minus 1 whole cube wala question jo humne kiya tha, it can be easily solved with that. So if I take this as A and if I take this as B, again this question can be done in both the ways. We did that question in two ways, right? So this also can also be done in two ways. Right now we are taking the first way, that is a cube minus b cube identity. So a cube minus b cube, again if I write the identity, what it is, a minus b, a square plus ab plus b square. So now let's do it. 2x plus 2y minus 3x. Now again put it in bracket. It's better for you to avoid plus minus confusion. We are not in hurry. Okay. So let's make one more step. Now 2x plus 2y the whole square, 3x minus 3y the whole square plus the multiplication of the two. 2x plus 2y and 3x minus 3y. Let's check. Is it clear to all? Now if I just open the brackets, what will I get? 2x plus 2y minus 3x minus minus plus 3y. What will you get here? 4x square. We are going to apply the identity again. A plus b whole square plus 8xy. 3 cube is what? 27x cube. Sorry, square. So we get 9x square, 9y square and 2ab. 2ab will be what? 18xy. And for the next two terms, we have to use simple multiplication as no identity can be applied there. So what are we going to multiply? 2x with the entire term. So what will you get? 6x square. 2x into minus 3x minus 6xy. Then 2y with 3x, that is 6xy. And 2y with 3y minus 6y square. Just be careful with the plus minus signs. Now, 2y like terms can be added or subtracted. Just keep that thing in mind. So, 2y plus 3y, 5y, 2x minus 3x minus x. Now, let's see the like terms here. 4x square, 9x square and 6x square. So, how much you get? 4, 9 and 6. So, what will you get here? 19x square. Correct. 4y square 9y square is 13y square and here we have minus 6y square. So 13 minus 6 is 7y square. Just move with the terms. Now we have 8xy minus 6xy and plus 6xy. So these two will get cut. So we have only one term left out, 8xy. Right? Now we have the next term, minus 18xy. Correct? Just check here. It should be xy. Correct? Now all terms are used. Correct? Now let's solve it again. So we get what? The final step, 5y minus x, 19x square plus 7y square, and 8xy and minus 18xy. They both are going to be, yes, minus, correct, 10xy. Clear? So this is the factorization of the above question. That is 8x plus y whole cube minus 27x minus y whole cube. So 8 can be written as 2 cube and 27 can be written as 3 cube. So you get 2x plus 2y whole cube minus 3x minus 3y whole cube. Now, if we use the identity of a cube minus b cube, we get a minus b, a square plus ab plus b square. So, 2x plus 2y minus, in bracket you will put 3x minus 3y, and a square plus b square plus ab. That is your next factor. So, what will you get? 5y minus x, and here we use the identities for a plus b whole square and a minus b whole square, and then for the last we have to simply multiply the terms, right? So this is how we did it. And then remember the concept that like terms can be added or subtracted, otherwise we cannot add or subtract the unlike terms. Right? Clear to all? Right, so these were few important questions for factorization, right? I hope you all have understood it well. Okay, thank you everyone.